The Big Bang Theory isn't just an idea, it's supported by powerful scientific evidence. As the universe expands, galaxies move away from us, creating a phenomenon known as redshift. Scientists have also detected the cosmic microwave background, the oldest light in the universe, along with gravitational waves that reveal violent cosmic events. Together, these discoveries provide compelling evidence that our universe began with the Big Bang. As galaxies move through space, their light changes color due to the Doppler effect. Galaxies moving away appear redder, a phenomenon called redshift, while those moving closer appear bluer, known as blue shift. Edwin Hubble discovered that the farther a galaxy is, the faster it moves away, revealing that our universe is continuously expanding. Although space appears completely dark through an optical telescope, sensitive radio telescopes reveal a faint microwave glow filling the entire universe. This is the cosmic microwave background, the oldest light ever detected. A relic from the Big Bang, it provides powerful evidence that our universe began 13.8 billion years ago and has been expanding ever since. Over a century ago, Albert Einstein predicted the existence of gravitational waves, tiny ripples in the fabric of spacetime. These waves are created when massive objects, like black holes or neutron stars, collide. In 2015, scientists at LIGO made history by detecting these ripples, confirming Einstein's prediction and opening an entirely new way to explore the universe. In 1915, Albert Einstein revolutionized our understanding of gravity with his theory of general relativity. He revealed that space and time form a single fabric called spacetime, and that massive objects bend this fabric, creating what we experience as gravity. Discoveries like gravitational lensing and gravitational waves have since confirmed his remarkable theory. Gravitational waves do more than confirm Einstein's theory. They help scientists measure how fast the universe is expanding. By combining these ripples in spacetime with light from distant cosmic events, astronomers can calculate the Hubble Constant more accurately, bringing us closer to understanding the origin, evolution, and ultimate fate of the universe. And that brings us to the end of today's journey through the universe. If you enjoyed exploring the wonders of space and science, don't forget to like this video, subscribe to the channel, and turn on the notification bell so you never miss our next adventure. Thanks for watching, and until next time, keep looking up, stay curious, and never stop exploring the cosmos.